I am going to provide a detailed explanation of the Probit regression model by utilizing the Finance Research Gate website. Therefore, I will begin by looking at a single frequency due to the fact that both the x and the y variables possess the exact same frequency throughout the entire dataset. I'll begin by selecting the entire period under consideration, which will allow us to proceed with our analysis more efficiently. Subsequently, I will delve into a detailed explanation of how key financial metrics such as leverage, overall profitability, the efficiency of converting revenue into cash, and the fundamental size of an entity collectively influence the Probit probability of experiencing 2 consecutive periods of losses. So let me make my selection for the leverage, size, rating, profitability. And finally, we need to consider how effectively our reported revenue translates into available cash. The y variable is a binary variable, meaning it can take on one of 2 distinct values, either 0 or 1. A value of 0 indicates that the firm did not experience 2 consecutive earning losses. A value of 1 conversely means the firm did experience 2 consecutive earning losses. So I'll be looking for that specific binary variable. It has already been computed for you, so you won't need to create any dummy or binary variables yourself. So to reiterate, the binary variable takes a value of 1 specifically when the firm records a negative net income figure for 2 successive financial years. Next, we'll proceed rather quickly to log all of our independent or X variables, which is typically the standard practice within academic research. This is primarily done to ensure that these variables are recorded and processed prior to our dependent or Y variable. Once these have been successfully added to our dataset, we will then scroll down through the interface to take a brief initial look at the descriptive statistics. We frequently observe extreme observations, specifically those that fall above the 99th percentile and also those found below the 1st percentile. Consequently, we need to address this, and we do so, for instance, by implementing a process called Winsorization. Our intention is to Winsorize each and every one of the variables. In this particular case, it doesn't truly matter to Winsorize the y variable because we don't have any extreme observations. We simply have 0 and 1, but I will include it just in case, just to show you that it should be the same. Y key. And now we are going to set the Winsorization level to exactly 1%, and after that we will proceed to generate all of these new Winsorized variables. So what we can clearly observe here is that the Winsorized data points are significantly less influenced by those extreme observations, and this is a really crucial aspect to consider before we proceed with running any kind of regression analysis. It's quite important. And regarding the Winsorized y variable, if you take a moment to compare its mean value right here with the mean of the original untransformed data, you'll notice that they are in fact identical. Even when we look at the other descriptive statistics, such as the median value, it should remain exactly the same, primarily because the y variable did not contain any extreme observations or outliers to begin with. Now, let us continue by scrolling further down to the section for advanced regression analysis, where we will find both the logistic and the Probit regression models. So, let me take a moment to select the y and the x variables for our graph. For our analysis, I've carefully chosen these 4 specific variables, which we'll refer to as our X variables, and then to begin our statistical modeling, we'll start by employing the Probit regression. While these 2 models are quite similar in their overall approach, it's important to note that there are some distinct differences between them, particularly concerning the interpretation and magnitude of their coefficient values. But both of these deal with the situation where the variable is binary. So when the y variable takes only 2 values, we are observing if an event occurs or not. In this case, we have a firm that has experienced 2 consecutive years of losses or it has not. Then, in our analysis, we are presented with a clear binary choice or a specific outcome that can only take one of 2 distinct values. Consequently, to properly model this kind of data, it becomes necessary for us to employ one of these specialized regression techniques. Now, specifically, the Probit model provides us with the estimated coefficients here, and these particular estimates are designed to directly indicate the underlying probability of that specific outcome occurring. Right now, at this particular point in the process, we have the option to manually set the y variable as binary. However, there's no real need for us to actually select that specific setting because our y is already a binary variable by its very nature. If you take a moment to scroll further down the page, you will see that it provides us with a detailed look at the overall fit of the statistical model. For example, the observed likelihood ratio in this case is highly significant, clearly indicating that the inclusion of these 4 x variables is extremely important when contrasted with a much simpler model that consists solely of a constant term. So these specific numbers, this particular one, this one here, and also this final one, they are essentially comparing the performance of this model, which incorporates 4 x variables against a much simpler alternative model that only includes a constant term. And from these results, it's quite evident that we've achieved a significant improvement because the values presented here are quite substantial. Ideally, the AIC or Akaike information criterion would be at a much lower value. However, considering the specific parameters and context of our current analysis, this particular value for the AIC is actually quite normal and acceptable. Moving on, our next step is to delve into the detailed description of the Probit model. In this particular case, looking at the coefficients right here, if you select a firm and identify the values for x1, 2, 3, and 4, then multiply each of those by its coefficient and calculate the final fitted value that will provide you with the latent variable, which is what we refer to as the z-score. The z-score is a fundamental concept that refers to the standard normal distribution, which always possesses a zero value as its mean and a broad range of values, mathematically speaking, from negative infinity all the way to positive infinity, but normally falling between -3 and +3, which is exactly what you're going to cover during this particular session.
The majority of them, in fact, most of the observations.
So, a zero in this instance signifies that we possess a certain value. It's not truly a zero, but more accurately the single reference point, since we're working with a standardized measurement. Now, once we obtain the latent variable from these calculated coefficients, we can then convert that value into a meaningful probability, and this is precisely where we find the key difference between the Logit and Probit models. Specifically, with the Probit model, we employ a particular functional form. This means that we are going to utilize the cumulative normal probability distribution for our calculations. Once we convert that z value into a probability, we will then obtain a clear probability outcome. We follow a similar process with the logistic model, but the logistic function employs a distinct mathematical form. We specifically utilize this particular functional form to derive the final probability. While one of these approaches, you see, fundamentally relies upon the principles of a normal distribution, while the other method, in contrast, is built upon the characteristics of the logistic distribution, and specifically in this particular instance, we are looking at SS6. We've actually gone into quite extensive detail on this very topic previously within our dedicated logistic regression video. So for a more comprehensive understanding, you are certainly welcome to refer back to that resource. So if you are going to compare the coefficients, you'll observe that we have a negative coefficient specifically for profitability. This particular finding is entirely expected, meaning that the probability would actually become lower if we possess a higher level of operating profitability. So, considering this, let's hypothesize that we observe an increase in our operating profitability, specifically by 10%. Consequently, if we take this 10% and multiply it by the established coefficient, we would then anticipate a resulting change in the latent z-score amounting to negative 0.13. So the new z-score will effectively shift its position from what we typically define as the normal or baseline level, which is represented by 0, to a new calculated z-score, which now stands at minus 0.13. That represents a decrease of 50 with a commutative probability of 2.44. This calculation indicates that it will ultimately translate to a significant reduction of nearly negative 5.4%, or more precisely, a drop of 5.4%. If we decide to utilize the Logit model instead, we are certainly going to obtain various coefficients, but they are definitely going to possess significantly different values because the specific functional form that establishes the link between the z-score and the probability is fundamentally different. Now, right here, for a quick example, let us just say that we had a substantial increase of overall profitability by exactly 10%. So if you were to multiply 10% by this specific numerical value, that calculation would then translate to a precise figure of 0.55. Consequently, the new z-score, as derived from our logistic regression analysis, would then effectively become 0.55. This implies that we are shifting from an initial probability of exactly 0.5, which is the central point where the z-score is precisely equal to 0, because the underlying statistical distribution, the overall probability of the specific distribution, is exactly 0.5 whenever we have a z-score that is equal to 0. However, if the z-score changes to negative 0.55 as a direct result of the increase of this value by 10%, then the resulting probability would go down to 0.36, which means that we have a total reduction of 13.6%. So, in both of these individual cases, we are seeing a reduction, but in the logistic model, we observe a much greater reduction in probability because we are utilizing a different functional form. Nevertheless, both of these approaches should point us toward a very similar conclusion. That is going to be all for our lecture today. Thank you very much for watching.